All right, we are looking at our next section of the topic 5 notes. We're talking about mid segments of triangles. Talking about mid segments, okay? So, our essential question: how does a mid segment relate to the measures of a triangle? Um, and for this one, we are going to need our notes packet. We are looking at the mid segments of triangles. And so I guess the first question is, what is the mid segment? Okay. This picture is a pretty good diagram of what a mid segment is. Okay. So a mid segment is a segment. It's exactly what it sounds like. It is a segment that joins the midpoints of two sides of a triangle. So what that means is that if DE is a mid segment, that means this point right here and that point right there are the midpoints of the two sides of the triangle. Okay, and D is the midpoint of side AB, and E is the midpoint of AC. Okay, so if D is a midsegment, what do we know about AD and BD? What do we know about AE and CE? Well, this is just using the definition of a midpoint. That's the point that's in the middle, right? So the point that's in the middle, that means those side lengths are congruent to each other. Okay, that means they're congruent. When we look at that on the diagram, that means AE and CE are congruent. That means AD and BD are congruent. So they each get those hash marks right there. All right, they are congruent to each other. That's what that means. So DE would be a midsegment of triangle ABC. Next thing we want to talk about is the mid-segment triangle. And it is exactly what it sounds like. Okay? It is a triangle formed by all three of the mid-segments of a larger triangle. So that means D and E are both midpoints, and F is also a midpoint. Okay? D, E, and F are the midpoints of the sides of that triangle right there. So that's what brings up this concept right here is what brings up the question on the next page of your notes. Okay. I believe on your packet it probably got cut off. The question up at the top. Okay. This is what it was supposed to say. What are the vertices of the mid-segment triangle when A, B, and C are the vertices of your given triangle? All right. So let's look at this. If those are your vertices, A, B, and C are the vertices of your given triangle, then what are the vertices of the midsegment? Okay, so the midsegment triangle, like we were just saying a minute ago, is a triangle formed by the midsegments. Okay, the midsegments, remember from back here, connect the midpoints to each other. So when we talk about the mid-segment triangle, we're talking about a triangle where the corners are the midpoints. Okay, so what we're going to do on your paper, mark off these 3 points. Okay, these are the vertices of the triangle that we start with. And if we're trying to find the mid segments, all we have to do is know where the midpoints are. Okay, and for that, we just go back to the beginning of our notes packet and we look at the midpoint formula. Okay, the midpoint formula, what we did was we took 2 points, and what we did was we took the average of the x values and the average of the y values, and what that did was it found the middle ground, the point that was exactly in between the 2 points that we started with. Okay, we found the middle ground of the x values, the middle ground of the y values, and that's exactly what we're doing right here. In between point A and point B, we've got x values of -5 and 3, so we add them together, divide by 2. We've got y values of 6 and 8, add together, divide by 2. And all of this simplifies down to give us a point of -1 and +7. So let's mark that as a midpoint. -1 and +7. I'm going to use a different color. -1, +7. That is our first midpoint that we're dealing with. Okay? We do the exact same thing with point B and point C. The x values are 3 and 1, so we add them together, divide by 2. The y values are 8 and -4, and then divide by 2. That gives us a 0.22. So that's our next midpoint right there. Okay, we do the same thing now with our last 2 points. Point C and point A is the only combination we have left. X values of 1 and -5, Y values of -4 and 6. Add together, divide by 2. That gives us our last midpoint of -2, +1. That right there, okay? So when a question asks, what are the vertices of the mid-segment triangle? What we're really asking right there, what we're really asking right there is not anything super complicated. What it's really asking is, what are the midpoints of the sides? Okay, that's the question that's really being asked there, is not what are the vertices of the mid-segment triangle. You just have to know what are the midpoints of the sides. These three things right across here are the points that we're looking for. All right, the next thing we're looking at is the triangle mid-segment theorem, and there are two parts of it. Okay, the first part of the triangle mid-segment theorem says, number one, that the segment connecting the two midpoints, okay, the mid-segment, first, it is parallel to the third side. Okay, so as we look at this diagram, if our mid-segment that we're talking about is DE, then DE is parallel to AC. That's the first part of it. DE is parallel to AC. The second part is that it is exactly half as long as that third side. So when we look at their measurements, DE is 1/2 of AC. DE is 1/2 of AC. All right? We can use that to set up a whole bunch of different diagrams, a whole bunch of different things. Take a look at this right here. Okay, we've got some diagrams that say DE is a mid-segment of triangle ABC, and it's asking us to find the value of X. All right, when we look at this right here, we look at this and we know the definition of a mid-segment. When we look at this, we know that DE, according to the theorem right here, is going to be half as long as the third side. Okay, so X is half as long as that one. X equals 1/2 times that one. So X is going to be 14 on that first one. When we look at our next triangle down here at the bottom, we see that we know by the theorem that the mid-segment DE is half of the length of this one right here. So 15 is half of the longer side, right? 15 is half of the longer side. So obviously X must be 30. This last one right here actually doesn't use that theorem. Okay, this last one right here, we actually need to know, what is a mid-segment? Okay, and the mid-segment, according to way back at the beginning of these notes, the mid-segment connects the two midpoints on the side of a triangle. So when we look at a picture like this, we have to recognize that E right here is a midpoint. So if this side is 9, then we have to also recognize that this side is the same thing, because that's the definition of a midpoint. X in this case is also equal to 9. Okay, this is a good exercise, this right here. Make sure when you're looking at these problems on your Canvas or on your assignments, tests, whatever it is, make sure you're answering the question that's being asked. Okay, this question right here doesn't actually ask anything about the third side. It doesn't ask about the length of the mid-segment. It's only asking about this one side right here. You need to be careful about answering the question that is asked. This next one right here, 8 is the mid-segment. What is the value of X? Okay, we already know from the theorem back over here that the length of the mid-segment is half of the longer side. Okay, the length of the mid-segment equals 1/2 times the longer side. So that's exactly the equation we can set up. The length of the midsegment, 8, equals 1/2 of the longer side. Okay? So this is going to be a tip. If you set up your equation like this, here's the way to figure this out. Whatever you have over here does not matter. If it's being multiplied times 1/2, the way you undo that is multiplying times 2 on both sides. Times 2 on both sides. Okay? That will get rid of this fraction right here. And that will turn it into 16 equals that longer side alone. Okay, this is a very easy equation to solve. We send the friends home, we subtract 4, and then we send the family members home, divide by 2, and x equals 6. Again, make sure you know what the question is asking for. Okay, if the question was asking for what is the length of the side, you could figure it out and say that it was 16. But in this case, the question is asking what is x, so we have to set up this equation to find x. This last one right here, using the triangle midsegment theorem. This is the last one on this section of notes, and it's asking about the perimeter of triangles. All right, so it gives you a bunch of information right up here. It says that D is the midpoint of AB, and E is the midpoint of AC, and F is the midpoint of BC. Okay, so that is the overly complicated way of just saying that these three things, D and E and F, are the midpoints, and this right here, that triangle, is the midsegment triangle. All right, so it's asking us to find the perimeter of ABC. Well, that's not necessarily a very easy thing to do, but what we can do very easily is figure out the perimeter of this inside triangle and then use this little piece of information down at the bottom. All right, so if we're going to find the last part of this triangle, okay, we've got two of the three sides of our inside triangle right there, our midsegment triangle. And if we've got two of those three, we can figure out that this last one, DE, is the same as half of this one right here, right? That's what our theorem said a couple of slides ago. Our theorem right here says that the midsegment equals 1/2 of the longer side. So look at this. On this picture, we've already got that 1/2 of this longer side is 5. So that means DE right here is also 5. Okay? This perimeter of our midsegment triangle, see, we already know that it's going to be 1/2 of 5 times 2, which is just 5. That's where we get that DE from. So we can take that 3 plus 4 plus 5 and get the perimeter right there of 12. Well, that little piece of information down at the bottom says that the perimeter of DEF is half the perimeter of triangle CBA. Okay? This triangle DEF is half the perimeter of CBA, and that makes sense if you think about it for half a second. DEF, all of those sides are half the length of all of our purple sides right here, right? So of course the perimeter would be half of it, because we're just adding up half of the lengths. So if our perimeter on this inner one is 12, then the perimeter on our outer one is going to be twice as much. Instead of 3 and 4 and 5, those side lengths are going to be, instead of 3 and 4 and 5, those side lengths are going to be 6 and 8 and 10. All right, so we add those up, we get a perimeter of 24, and that's what answers our question. Again, be sure you are answering the question that's being asked. The question is asked, find the perimeter of triangle ABC. Okay, we used the perimeter of the inside to find it, but that doesn't mean that's our final answer. Our final answer is to look at the question that's being asked, which is going to be 24, not 12. All right. That is all we've got for today. There are some Canvas problems, and we'll hope to see y'all again very, very soon.